Okay, one last applications, and this time we're going to go back to our rectangle problem, only this time there's a little bit of a twist. Our rectangular area is being formed along a stream to form a picnic area. So we're not talking about a shed floor with a fixed perimeter. We are talking about a picnic area. And if you think about the situation, we've got a stream here. Let me put my stream in blue. Blue's a nice color for streams. So we've got this stream here, and it's going along. And right next to this stream, of course, we're going to put our picnic area. Well, what do we know about this picnic area is that we don't have to have a fence along the stream because we can just put our fencing along the side of the stream right here. Okay, so we're going to get this rectangular fenced in area here. And we don't want to go outside of our fenced in area, so this is where our picnic area is going to occur. And we want to ask, well, what should be the dimensions of this rectangle that will produce the maximum area? Will it be a square again? Well, let's find out. We're going to have, in this case, one length of fencing along the long side parallel to the stream, and two lengths of fencing that come directly out from the stream. Now, for the intents and purposes of our demonstration here, we can assume that to also be a straight side so that we can form a nice rectangle right here. So we'll assume that's a nice straight stream, even though not all streams are nice and straight. What do we know? Well, we know the perimeter of 100 feet of fencing must cover that 1, 2, 3 sides. So 100 feet of fencing will equal our length plus 2 times the width. Well, that's helpful because next we're interested in finding the area. And the area, well, the area works the same as every other area of a rectangular figure that we've ever talked about. The area is equal to the length times the width. So what do? We're going to rewrite our equation for area in terms of either L or W. And it looks to be that solving for L is the best way to go about this. So we would say that L, the length of this fencing, is equal to 100 minus 2 times W by subtracting 2W from both sides. And we're going to make this substitution into our area formula, and we're going to come up with an area equal to the length, L, times the width, which is, let's try that again. We've just solved for L, so we're going to have to replace L with 100 minus 2 times W times the width, W. Right? Notice that all we're really doing is just replacing length in this formula here. Okay, so what does that mean? Well, our function now, area, is in terms of the width. So the area in terms of the width is equal to 100 W minus 2W squared. And lo and behold, we have another parabola. So we're going to be looking for the vertex of this parabola. In this case, our parabola is of the form negative 2 times W squared minus or plus 100 times W in this case. So let's go ahead and pick out A for our formula be negative 2, B for our formula be 100. And we're going to say that W is going to have a maximum at the negative of B divided by 2 times A. So that's negative 2. So our width comes out to be 25. 25 feet seems to be where this occurs. And now we can go back and say, well, okay, if the width is 25 feet, then our length would be 100 minus 2 times the width, which is to say 100 minus 50 or 50 feet. So it's not a square this time. It turns out that our length and width is going to be a 50 feet length and 25 foot width as our picnic area. So that's our solution. Okay, good luck with the homework. I'll see you in class.